Sound or terrifying little animal juice is a pink monster with a colossal name. Assuming you set it in the position where the planetary gathering is, it would expand to the circle of Jupiter. It's immense, uncommonly wobbly, and appears prepared to detonate. Scarab juice could probably detonate at any second. The superstar horrible minimal creature juice is both animating and stupefying. This purple, huge, tremendous name inside the Orion constellation showed strange behavior when it got fainter in late 2019 and early 2020 than any time in the last 100 years. It quickly became almost as dim as bug juice, Orion's third most impressive star. The darkening became the sign of this event. However, alarming minimal creature juice has since regained its brilliance, transforming into the brightest massive name in Orion for several days this year, more magnificent than ever before. Speculation about its looming obliteration as a supernova arose due to these events. Is there any evidence for this idea? Will the red giant superstar scarab juice explode during our lifetime? What impact would such an event have on Earthlings like us? Join us as we explore the potential impact of the horrendous little animal juice's pompous explosion and the warning from Brian Cox. Cox warns that since humans may be the only sentient species in our system, wiping out our progress could have devastating results for the entire world. Cox delves into the Goldilocks hypothesis of the universe, emphasizing the careful conditions over billions of years that made Earth habitable. Despite the fact that the star at the center of our solar system has not undergone massive changes in nearly 4 billion years, experts estimate it is halfway through its life cycle. Right now, it transforms 4 million tons of helium into energy through fusion, converting 600 million tons of hydrogen into helium every second. This hot plasmasphere is the fundamental power supply for life on Earth. However, experts predict it will dissipate in around 5 billion years, causing a significant change in the universe. Cox revealed how this might unfold in the BBC's Wonders of the Universe series. You might think the universe is static, but stars are inherently transient parts of the sky. Despite shining brightly for thousands or billions of years, their future is limited by their ability to consume hydrogen. A star like our Sun begins to evolve as it approaches its death. When its hydrogen runs out, it doesn't die peacefully. The Sun will not simply fade like a ghost. Its outer layers will expand as its fuel dwindles, and its core will collapse, producing more heat. Cox warns that the Sun's changes will affect Earth significantly. He explained that this could tragically impact our fragile planet in roughly 1 billion years. There might be one last perfect day on Earth as the planet becomes hotter, but eventually, all life will be unable to survive. The Sun will have expanded to fill the entire horizon. Long after human life has vanished, its final great phase will see it transform into a red giant. Even so, the Sun will continue to evolve after humanity has disappeared. In 6 billion years, our Sun will explode, releasing massive amounts of fuel and dust into space to form a large cloud. It will be a faint ash at its center, a shadow of its former grandeur, and smaller than Earth. Our Sun will have turned into a white dwarf. This process will likely render life on Earth impossible. NASA's New Horizons mission leader, Dr. Alan Stern, suggests that it could also create habitable worlds in the coldest regions of space. Dr. Stern believes that any survivors might find refuge on Pluto or other distant dwarf planets within the Kuiper Belt, a region of icy objects beyond Neptune. These worlds' conditions will inevitably change as the Sun evolves, turning them into potentially habitable planets. Most stars exist in a steady state, shining with consistent brightness. However, there are exceptions. Some stars, known as variable stars, experience changes in brightness. The most famous is Mira, often referred to as the Star of Wonder. Initially studied in 1596 by German minister David Fabricius, Mira is a pulsating star that periodically expands and contracts. Another example is Algol, which displays periodic eclipses from a companion star. About 30% of these variable stars are visible to the naked eye, though it takes skill to detect their changes in brightness. You may already know about the upsetting Crawley juice, even if you don't recognize the term. It's one of the brightest stars in the night sky, forming a significant part of the Orion constellation. Crawley juice is a red giant so enormous that it could easily engulf Earth, Mercury, Venus, Mars, and possibly Jupiter if it were at the center of our solar system. Despite its distance, approximately 400 light-years away, though estimates range up to 600 light-years, its size and brightness make it observable. The most brilliant of the variable stars, Betelgeuse is the fifth brightest star visible from Earth. This star periodically changes in brightness, sometimes almost matching the brightness of Rigel, Orion's fourth brightest blue star. Though not as regular as Mira, the changes are still noticeable. Occasionally, a star can suddenly become incredibly bright. These supernovae are the brightest and rarest events, potentially visible even during the day. Astronomers dream of witnessing a nearby supernova, an event so rare that few people ever observe it. Betelgeuse has consistently fascinated astronomers due to its prominence and behavior. Scientists predict its dramatic finale could occur at any moment, though we cannot be sure when. Stars of this magnitude collapse under their weight when their fuel is exhausted, resulting in a spectacular explosion. When Betelgeuse, also known as Betelgeuse, reaches the end of its life, it is expected to go supernova. This dramatic explosion will release immense energy and material into space, potentially forming new stars and planets from the remnants. The event would be visible even during the day and could outshine the full moon for weeks. Astronomers closely monitor Betelgeuse not only for its fascinating behavior, but also because its supernova would offer a rare opportunity to study such a phenomenon in detail. Despite its potential to end in a spectacular explosion, Betelgeuse's distance of 400 to 600 light-years ensures that its supernova would not pose a direct threat to Earth. However, it would provide invaluable insights into stellar evolution and the cosmic recycling of matter. Betelgeuse's story highlights the dynamic nature of the universe. Massive stars like it play a vital role in the cosmic cycle, forging heavy elements in their cores and scattering them into space through supernovae. These elements become the building blocks for new stars, planets, and even life itself. Brian Cox and other scientists emphasize that while the death of stars like Betelgeuse may seem catastrophic, it is also an essential part of the universe's renewal process. Such events remind us of the delicate balance that sustains life on Earth and the intricate interconnectedness of the cosmos. The Sun, much smaller than Betelgeuse, will follow a different path at the end of its life. After exhausting its hydrogen, it will expand into a red giant, engulfing the inner planets. Eventually, it will shed its outer layers, leaving behind a white dwarf, a dense, faint remnant of its former self. This transformation will mark the end of the Sun's role as the primary energy source for our solar system. As humanity contemplates its place in the universe, stories of stars like Betelgeuse and the Sun continue to inspire awe and curiosity. They remind us of the fleeting nature of existence and the enduring beauty of cosmic creation and destruction. Even with their eventual demise, stars like Betelgeuse leave behind a legacy. The heavy elements they create during their lifetimes and their explosive deaths enrich the universe, paving the way for new generations of stars and planets. Betelgeuse, with its unpredictable brilliance and immense size, is a testament to the ever-changing and awe-inspiring nature of the cosmos. Astronomers remain vigilant, observing Betelgeuse for any signs of its impending supernova. While it is unlikely to occur within our lifetimes, the star's eventual explosion will be a monumental event, one that will captivate both scientists and the general public. The light from this stellar finale will travel across hundreds of light-years, reaching Earth as a brilliant reminder of the universe's extraordinary scale and power. As Betelgeuse continues its celestial dance, scientists are captivated by the star's unpredictable nature. The mysterious dimming episodes, such as the one in late 2019 and early 2020, sparked global interest and raised questions about the star's stability. Observations revealed that these fluctuations in brightness were caused by surface phenomena and mass ejections, where clouds of gas and dust temporarily obscured the star's light. This behavior highlights the dynamic processes occurring in massive stars like Betelgeuse. Their outer layers are turbulent, with convection currents bringing material from deep within the star to its surface. These currents create massive plumes of gas that can cool and condense into dust, temporarily altering the star's appearance. Despite these surface changes, astronomers assure us that Betelgeuse's supernova is not imminent. Based on current models, it may take tens of thousands of years before the star exhausts its nuclear fuel and collapses under its gravity. However, the precise timing remains uncertain, as our understanding of stellar evolution is continually refined. When Betelgeuse eventually explodes, it will be a once-in-a-lifetime cosmic spectacle. The supernova could briefly make Betelgeuse one of the brightest objects in the night sky, rivaling the moon's brilliance. The explosion will emit a dazzling array of light across the electromagnetic spectrum, including gamma rays, X-rays, and visible light. Although the supernova will not directly harm Earth due to its distance, it will have significant scientific implications. The explosion will create heavy elements, such as gold, platinum, and uranium, which will disperse into space, contributing to the chemical enrichment of the galaxy. These elements are crucial for forming new stars, planets, and even life. Betelgeuse's eventual demise underscores the transient nature of stars and the interconnectedness of the universe. The elements forged in the hearts of dying stars are the building blocks of planets and living organisms. Every atom of carbon in our bodies, every molecule of oxygen we breathe, was created in a star like Betelgeuse billions of years ago. This cosmic recycling process, known as nucleosynthesis, is a testament to the universe's ability to regenerate and evolve. It reminds us that our existence is intricately tied to the life cycles of stars. As we study Betelgeuse and other celestial phenomena, we gain a deeper appreciation for our place in the cosmos and the forces that shape our universe. Astronomers are preparing for the eventuality of Betelgeuse's supernova by refining their observational techniques and developing advanced instruments. When the star finally explodes, telescopes worldwide will capture every detail, providing a treasure trove of data for scientists to analyze. This event will offer an unprecedented opportunity to study the life cycle of massive stars and the mechanics of supernova explosions. Until that day arrives, Betelgeuse continues to shine as a beacon of wonder and mystery. Its fiery glow and enigmatic behavior serve as a reminder of the dynamic and ever-changing nature of the universe. As we gaze up at the night sky, we are reminded of the vastness of the cosmos and the timeless processes that shape it. In the grand scheme of things, Betelgeuse is but one star among billions. Yet its story captivates us, connecting us to the broader narrative of the universe. Whether it explodes tomorrow or in millennia, Betelgeuse's legacy is assured, symbolizing the beauty, power, and impermanence of the stars that light our skies.